Okay, good to know that all of you have visited IA before. Let me welcome you. Is live started? Okay. A very good morning to all of you. Welcome to IA. My name is Vikrant and I work in the outreach section here. Let me briefly introduce IA to you. So we're a premier research institute in astrophysics. So yes, we study galaxies and cosmology and stars, sun, solar system, exoplanets, all those kind of things. Today we're celebrating the anniversary one day before of something called the International Asteroid Day. And this is an anniversary event of the 1908 30th June event that happened in Siberia. There was an asteroid impact on the 30th June of 1908, and we celebrate its anniversary on 30th June, but since tomorrow is a Sunday, we are doing it today on a Saturday. To give a public talk on this event, we have with us Dr. Shyalaja, who was a former faculty here at IA, and she also did a PhD in Wolf-Rayet stars here in IA, and later on she moved to become the director of the Jawaharlal Nehru Planetarium here in Bangalore. She's been a very active science communicator as well, and she's done some really good work in converting astronomy to Kannada language. And lately, she's taken on a huge interest in the history of astronomy in Karnataka, and she's with us as well at the Cosmos project of Mysore. Without further ado, I'd like to invite Dr. Shyalaja for her talk.
Thank you. Okay, it's on. You people can hear me through the mic. Okay, now I have given the title as From Unwanted Intruders to Space Rockets. This latter half, perhaps you can understand very easily because it has been in news in recent times quite often. But what is this unwanted intruders? That must be the thing that must be bothering you, as it did for the organizers here. I will just come to that. Before that, this is the definition of solar system as we know today. There are 8 planets and there are dwarf planets, asteroids, and so on. There are so many other things that also need to be done. But this is the understanding of the solar system as we know today. And out of them, this Ceres, this is the object which is of interest. The asteroid belt is here. I will have to bring this into discussion at least 3 or 4 times. It's a very interesting object. So why was it called, why did I give the title as Unwanted Intruders? I worked with the 1 meter telescope at Kavalur, and people were taking images of this kind. This is from anyway ESA. This kind of image, it would take hours for them to get it from, because those days it was not digital but regular plate holders. So they would expose it for 3 hours or something. And then they would develop it in the dark room, and the first thing they would look for was the quality, because every dot there they would measure. They would measure the diameter of every dot or the intensity of every dot, and based on that they had to come to some interesting conclusions. Do you see something odd there? Here. Can you see one? Can you see one here? Can you see one here? These are the intruders. So they hated them. So that is why I called them as intruders. And as long as the exposure was going on, the observer, there was an observer here, Professor Scaria. He was an expert in taking pictures of this kind with the 1 meter. He would be praying, I hope there will be no such thing. These were the unwanted ones. These are the asteroids. How do you know that these are the asteroids? Because they have moved. In 3 hours, they have left a streak there. So these were the ones which was not liked by the astronomers at all. And it was not special about the thing that was happening in Kavlu, but everywhere else also. All the observatories, the astronomers did not like this. They were a big botheration. So this entire region, if you had something interesting there, you have lost. You have lost the information on that. And maybe you will have to give another exposure again, hoping that no other streak will come there. That's how they were intruders. And at the end of the talk, you will know that we can call them as intruders also because we are hopefully living peacefully on the earth. And these are intruders. They are going to disturb our peace here. So let's understand how that is. And I mentioned about Ceres. It was discovered by this PSE on the 1st January of 1801. Everybody was celebrating New Year Day, but this person was seriously observing. And he saw the dot. No photography though. So he could see that a dot had changed the position from day to day. And he noticed that that should be the asteroid. The word asteroid was not there. They were looking for a planet. Because when you do some kind of an empirical relation, if you derive for the distance of the planets to their orbital period or something, you will find that there is a huge gap between Mars and Jupiter. This was called, it is Bode law. It was an empirical formula, and so they wanted to somehow fill in that, and this rightly fitted there. So they thought they have discovered a planet. So it was called a planet. But then subsequently they realized that within a few years they've discovered many more of them. So these are not planets, there are so many of them. So they called them minor planets. So from planet it became minor planet. And from a minor planet, the word asteroid was coined, so it was called an asteroid. And 10 years ago, 15 years ago, they became dwarf planets. So this is the prototype of the dwarf planets. You have to look up for what is the definition of dwarf planet, etc. Then you will understand why this had to happen. Okay. So asteroids are generally called main belt asteroids if they are between the orbits of Jupiter and Mars, and Kuiper belt if they are beyond the orbit of Neptune. There is another group there, there is a group here. And this is very interesting. This is the orbit of Jupiter, and you find some of them clustered in the Lagrange points L4 and L5. These are called the Trojan asteroids. They are named after the Trojan war heroes. So they were called Trojans because they are always in this position. So as Jupiter moves, these also move. So they share the orbit of Jupiter, but they are concentrated here. In recent times, they have found that they keep moving from here to here and like. But in any case, they are in the same orbit for all practical. So these are Trojan asteroids. And there are some mischief makers, those who leave the belt and keep coming like this. Some of them come inside also. Based on to what distance they approach, there are groups called Apollo, Amor, Aten, Atira, all these are the subgroups. The ones which come inside to the inner side of the solar system. And now the term near Earth asteroids also is very popular. Now, how did they discover them? This is the method. There used to be an apparatus below it called blink apparatus, and there they would put the two images taken a few hours apart or a few days apart, and you would see that one particular dot is changing the position. Based on that, you calculate the orbit and other details. That's how it was done. This was the blink apparatus, and they would put the two plates, one here and one here, and this was a manual operating device like this. You could one see this, next this. So the same blinking operation that you did, I showed in the previous one, you would do here. It was a mechanical setup, and it was here. The instrument was here, the floor below in that room. So this was the blink comparator, and it was used for discovering these things, and many asteroids were discovered here. I will tell you about it later. So these are all bodies which are not planets of different sizes, that is for sure. But then it just passes by the Earth, you call it an asteroid. It may not even pass by the Earth, but it keeps moving in the solar system. And if it burns up in the atmosphere, you will see a streak of light that you call as a meteor. And in case it lands onto the ground, then you pick it up and then you call it a meteorite. Then it becomes the property of the Geological Survey of India. Okay, so that is it. So from astronomy, it goes to the geologists. So these are the various terms that you encounter in this. So you have, these are all the irregular bodies, small bodies that are there in the solar system. So you have the comets, which also are odd shaped like potatoes, and you have a meteoroid, which can do any of these things, and you have the asteroid, which is only larger in size. So the size can be from 1 meter to hundreds of kilometers. And then you have the meteor, which is a small particle which passes through the atmosphere, it burns and creates a streak of light. So people mistook that the star is falling, so that is the meteor. And you have the meteor shower. Once in a while, the Earth passes through the. You can come to this. Yeah.
Mic a bit more up.
Up. Is that okay?
Yeah.
Okay.
Is it
I don't. I think in this room I'll be audible anyway. So you have the meteor showers when the small dust particles in the orbit of a comet or that enter. How do they enter? Because these particles are scattered all over the orbit, and Earth passes very close to that, and at that time they will come together. Then you will have a number of meteors in the sky on a given date, because this can happen once in a year. So you have the meteor showers on specific dates of the year. So August 12th, for example, there is going to be a shower. So that's about it. And sometimes they explode and create a very dramatic scene in the sky. They are called bolides or fireballs, depending on the intensity. And something that lands very peacefully onto the ground, and you can pick it up later, that is called the meteorite. So this is the basic definition of various terms that are encountered in this study. Among them, these near-Earth asteroids is a subgroup, and in that there is another subgroup called the potentially hazardous, PHA, because they come dangerously close to the Earth. When I say dangerous, it could be of the order of lunar distances, a fraction of a lunar distance. So it could be sometimes once or 1 or 2 times, or sometimes half of it, or sometimes 1/3 of it, and so on. Then they are really dangerous. They can crash onto the Earth. These are called the near-Earth asteroids. Now, this is the one, some kind of a image which shows that the red dots, there are so many of them which come, this is the orbit of Earth, they are hovering in the solar system. When you see a picture like this, you will really get worried because there are so many of them. But then you imagine the space, they are scattered over a huge area, so they don't even collide with each other. There is a lot of empty space available. So you have a alert notification whenever there is an asteroid which is coming close to the Earth, and they give an alert message within a few days so that people who have facility to track them can take a look at it. Generally, they pass peacefully and they are very small, so they are not visible at all generally. But when they come close to the Earth for those few hours, they become visible. So some kind of observations can be done with them. With that purpose, this alert notification is made available. And some of them pass through the atmosphere. They don't burn, but they just zoom through. They are safe. They leave also. things also have happened. One such photograph had appeared on the cover page of the journal Sky and Telescope. The photographer was very lucky, he was able to see them. And how these were formed? This is the question that people are trying to understand. So they formed right at the formation of the sun, even before the planets were formed. I think this existed. So there are two processes: the gravitational collapse and the turbulent diffusion, and each of them will give rise to some kind of a product. And you will see the asteroid only because of the gravitational collapse, and this will only diffuse into dust kind of a material. So both of them are there in plenty available all through the solar system. So this is one theory, and we need to study more and more asteroids to understand this. And this will tell you, this is some kind of a page of history which will tell you about what was the state of affairs at the time the sun was forming and the solar nebula was forming. And now this asteroid belt, they call it as a refugee camp. Because of the two different processes I mentioned, the chemical composition of these things that are formed at different distances from the center are going to be different. And in the inner side, these planets were formed, and most of the rocky asteroids, which are rich in silicates, they were pushed out from here and they took refuge in this region. Similarly, when the large ones like Jupiter, Neptune, and Uranus, they were formed, then the carbonaceous types were formed, and they also landed here. So this is something like a area where unwanted thing came and started settling down. So this is one argument. So what are the tools you have for studying these asteroids? You can do direct imaging. As I mentioned earlier, those streaks that I showed in the very first image, they have to be studied in great detail so that you extract some information. You could see that some of them were red in color, some of them were in green in color. That was because of the different filters that were used while photographing it. So that gives you the first-hand information on what is the type of asteroid. They are classified as carbon-rich or silicate-rich based on that. And if you want to do spectroscopy, how would you do that? And radar spectroscopy is another thing that you can do with the radio telescope. And another interesting tool is the occultations. I will just mention about these things. So this is, there is a camera behind this. How do I go back? Okay. This is the handy cam used by this Watanabe. So he attached a small prism onto this, and we use the handy cam to photograph the passage of the asteroid. And this is how the spectrum looks. So you can see that this is completely different from the spectrum you imagine for the sun or for the stars. And you can see magnesium, sodium, calcium, iron, all kinds of things there, because when they burn up in the sky, the meteor burns up in the sky, it emits light. So these are all, so this is of a small particle which entered into the Earth's atmosphere and burned up. He was lucky, he was looking in the same direction. And I think he must have waited for many, many days to capture this. Okay. Then this is the spectrum. So here you have taken with a grating. So you see that corresponding to the burning up, different lines you are able to see here. This is another simple technique. You cannot put a telescope in that direction, because by the time you turn the telescope to that, the event is over. Now these are the sun's spectral lines. You all know what is the meaning of spectrum. So these are all the dark lines that you see in the sun's spectrum. So the various elements have been identified. These are the transformer lines. Whereas in the case of the meteor, you will see them. Okay, this is in the case of the asteroid, you expect to see just reflected sunlight because they are shining by the sunlight that they are reflecting. So it should be exactly similar to that, but there is a difference. As you can see, these are the spectra that have been compared, and so these small differences from the sun's spectrum will tell you something about the chemical composition of the asteroid itself. Based on that, they have been classified. So if, you can't take a spectrum as good as the previous theoretical one was. So you just get some streaks like this. So for example, this is one asteroid, let's start. You see some gaps here, and these will have to be interpreted in terms of the content of silicate or water or whatever they have in them. So you have some meteorites samples, and when you see the similarity, you tend to think that this would have been classified an asteroid based on the spectrum when they were here. And so the S type, M type, carbon type, all different kinds of chemical composition is available in them. And so the main belt asteroids are generally the carbonaceous and silicate. And among the Trojans, you have a different variety. So you have to think of some mechanism for finding out how the Trojans went and landed into the orbit of Jupiter, and subsequently what happened to them. So all these kinds of studies are possible only by spectroscopy. Radar imaging will be possible when the asteroid is coming close to the Earth. So close that it is within the, let's say, lunar distance. Then they send images, they send radio waves from here and get them reflected. And based on that, they are able to, because you know right at what angle your radio waves are incident and they are reflected. So based on that, they will be able to get an idea of the shape of the asteroid. Okay. So this is a typical radar image. The size is only 1 kilometer. So identifying a 1 kilometer object at that height of 10,000 or 20,000 kilometers height is very difficult. And the same object came twice. They were able to do it because by virtue of its orbit, it came coming. And you notice the change in the shape. So how do you explain that? The asteroid may be rotating like this once. Second time when it came, it was rotating in a different direction. That means you will be able to get a three-dimensional image of the asteroid by these kinds of radar images. This is how the images look from the radio telescope, and based on that, they generate these kinds of models to explain this. The whole event will be over within, say, an hour or so. It just passes through and it's over. This is a very interesting occultation thing which you will be able to understand very easily. Let's say that there is a asteroid which is passing in front of a star. The star is very far away here. So this will cast a shadow of the starlight, if I can call it as a shadow. And in this shadow, let's say there are 5-6 observers at different locations on the Earth. All these observers will be looking at the star. They can't see the asteroid anyway. It's too small an object to be seen. But when they are looking at the star suddenly goes blank. There is no star visible. Say it may be for 10 seconds or 5 seconds or 3 seconds. They have to note it down. This is a very interesting hobby of the amateur astronomers. So once they get to know that there is an asteroid passage in front of the star, they need to just photograph that region with a very high spatial resolution. And what you get is that all the other stars will be appearing as streaks, but this one will have a gap. So that is a very interesting thing, and closely knit group of people with telescopes, they will do this. And it's very difficult with naked eye. Photograph only will be able to get this. So you have, let's say, 5 observers and they look at the star, and so if this is the shape of the asteroid, observer 1 will see the starlight disappearing for 2 seconds, reappearing for a while, and again it disappears for another 3 seconds, and then the star appears to be visible continuously. So the streak will have 2 gaps, whereas the observer 2 will have a continuous gap in the star streak, and this distance will be different from this. This time will be different from this. Similarly, this will be larger, and this will be larger, this will be smaller. So they have to combine all these things and generate some kind of an image of the asteroid like this. Observer 7 is also important. He did not see any dimming of the starlight. That means that's the limit. So this is the limit. If there was another observer here, that means you can very clearly work back and find out what is the size and shape of the asteroid. They are very odd shaped, like potatoes. They have all kinds of odd shapes. They are not spherical or oblate or spheroid. Okay. So this now here there are a series of there is an association called International Occultation Timing Association. You need to just time the thing very precisely and report it to them, and they will combine all the inputs from various locations, and based on that they will generate the. Now here this is the name of the asteroid, and here you see the gap here, and here this is another one. There is a gap here. So like this there are gaps. These gaps are very important for any study. So even now this network is very active, and this is a very foolproof method, I should say. A very interesting method for amateurs to do a collaborative work, and this has been going on. Even from here, there were many such passages which were recorded, and the sizes were derived from this institute also. So these are the actual readings, and this is the name of the asteroid Cleopatra. Once, this was in the year 1980, this was in another year. Now you can see that each time it presented a different orientation. So you can make a 3-dimensional model of the asteroid, even if you are not able to go and see the asteroid. That's why this was a very interesting observation. And then there are binary asteroids. These kinds of observations also revealed that there can be binary asteroids, that one is going around the other. And it remained a question till this spacecraft called Galileo. It moved through the asteroid belt and actually recorded a close-up shot of a binary asteroid. So if there are 2 of them going around each other, at a safe distance that they don't clash onto each other, it's a very stable binary system. So these also can be understood with the help of this occultation and spectroscopy techniques. When they land on the Earth, they create a crater. So now here is there are craters in India also. Lunar crater is one. There is another in Bhuj called Luna crater, and third one in Rajasthan called Jhal. And recently there was a paper on some kind of a crater which is lost in the forest area in South India. They have called it the Kaveri crater. So there are so many such things, but when they are in places like this is from Canada, you can see them from satellite imagery, or even from aircraft also will be able to see. I chose this one because you can see that there are 2 craters. It could be because of the impact of a binary crater. Maybe both of them came and hit the Earth. And the 2 are now appearing to be connected. There is another similar crater near Bonn in Germany. There, the highway passes this way. There is a crater on this side and on the other side. The 2 are not connected. There are 2 independent craters. It could be that the crater fell at 2 different events, or a binary fell together and created the 2. Either way, such things are very interesting to observe. Okay. This is the event which is responsible for the asteroid day. I don't know whether we should use the word celebration. We should have to use the word commemoration, because I don't think such a catastrophe is worth celebrating. We should not celebrate it. Well, nobody was killed. This was in a forest. I think some wildlife was lost. And the interesting thing was that all these trees were chopped off at a specific height. So that was something which made people wonder what could be the object that caused this. People could hear the sound, they saw the flash of light also, but this was in deep forest. There was no human habitation anywhere nearby. But subsequently, many years later, after the First World War, I think, people went and inspected the area, and they found that this was the situation. And so this is the large area that went into devastation here. So this is the former Soviet Union. So this is the explosion area, and then the effect of this blast could be traced over such a large region. So this was, in case if that was a city, it would be a very sad state of affairs, but fortunately it was a forest. And this is, the impact is hidden in the tree rings also. When the trees are chopped off, you can see the rings. The rings carry information on generally the sun activity, but here they are able to make out the 1908 mark also here. After this, again, the tree has survived and it has grown. So these kinds of very interesting things are recorded there. So what was it? We should really understand what caused it, and in case that were to happen elsewhere, what would have been the consequence. And this impact craters were given a lot of importance by this shoemaker, Caroline and David. These people studied the physics of the formation of the craters in great detail. He worked in the early 60s. Before him, people were thinking that all the craters that you see on the moon were because of the volcanoes. But he was the first one to bring in the idea that there can be craters caused by impact. Impact must have been a very frequent phenomena in the early stages of the solar system. And on the Earth, they are wiped out by weathering, but they have remained intact on the moon. He was the one who first proposed this, and he was involved in the Apollo mission also. And one of the objectives that he proposed was to study the craters on the moon. So he did a lot of work, and subsequently he discovered so many asteroids, so many comets, and so on. The most famous one is this. I'll show you later. So he proposed all these kinds of mechanisms of how the crater happens when something impacts on it, and what will be the consequence, and what you can infer from the crater that you see today. Because some of them have a lump inside. So what caused that? These kinds of things. Okay, this is the one. This is the comet Shoemaker-Levy. These are the two shoemakers, and this is Levy. The comet is named after them. This comet broke into 21 pieces. And they discovered it. When they discovered it, it was in the shape of a cigar. So they called it a cigar-shaped comet. But then they tracked it and found that somehow its orbit had changed, and it was going to crash on Jupiter. And all of us were witnesses to the event. It happened in '94. And Hubble Space Telescope was able to see that, whereas we were not on a favorable geometry. So we were not able to directly see it, but when Jupiter turned this way, we were able to see the scars. Even from this observatory, Kavlur and Hanley, they were able to record those scars, the black things on the surface of Jupiter. So they could even time piece number 1, 2, 3, 4. Entire schedule was prepared and accordingly it happened. So it proved two things. One is directly measuring what is the energy that is generated in these kinds of events. The second thing is that this is real. This is not something from fiction. Such things do happen, and therefore the theory of the craters on any planetary body is a reality. This was very important. Then subsequently they found this on Callisto. This is one of the satellites of Jupiter, and you can see that a similar thing must have happened. So all the different pieces have created a chain of craters on the surface. Now this method is also used for finding out the aging of the surface. So on the Earth it is not possible, but on all other bodies where there is no atmosphere, these will remain intact. And so if you measure the details of the crater and its surroundings, you will be able to get the idea of the age of the crater, of the surface also. So that leads to a branch called astrogeology. Astrogeology is the new branch of science for which these people were responsible. Okay. In India also, there were many such things. This happened in July 2020. So it created a hole. Overnight it happened, and next day they discovered that there was a hole. And I'm showing this so that people will not think if they see a hole like that in their field, they shouldn't imagine some supernatural forces to be creating it. It could be a simple case of a meteor. And they dug it out, and this is the size of the stove. And so this happened in 2020. There's an active team of people working in a physical research laboratory. They go and inspect these things, and then they take interest in doing these kinds of activities. Now it is in the museum, and they have given all the details of this. So from the surface, you can make out what is the kind of stone it is, whether it's a S-type or a C-type. So this will be available for study. And there was another one in Mukundapura. This was in 2017. So this, there were so many pieces, like charcoal. You get the idea of the size. See the footprint here. So you get an idea of the sizes of the small things, which otherwise you would have thrown as something, some piece of charcoal or something like that. You would have expected. But then they went and studied this also. And this is a close-up view. See how it has fragmented into small pieces. And this is also preserved. So, but all impacts need not be so peaceful. So if it falls on water, this tsunami it raises can be really very dangerous. If it falls on the land, then it creates the dust, and that dust will block the sunlight for a good number of years. Okay? So all these things are possible. So it will be decided by what is the asteroid, what is the size of the asteroid, and what are its components. Okay, for the second part, there is no option, it's there, then what is the size? So now we have to think of saving the humanity from these kinds of disasters, and therefore this day is important, so that we know that such things do happen, and we have to be prepared for that kind of an eventuality. So this was in February 2013. This happened in Russia. See, this is from a video, from a mobile camera they have recorded it. The video is available all over the net. So they could see that it blasted, but then they tried to look for the remnant, if at all it went and landed somewhere. I think they found a small piece, but then the light this was in the night. It is equivalent to a bright sunlit day. That's the kind of energy that it produced. So the impact energy is compared with, see, this is 10 to the power of 21. An earthquake of Richter scale 8 happens, the order is 10 to the power of 18, And the one that happened in Hiroshima, the nuclear thing, was 10 to the power of 30. So this is the order which makes you alert. That means you have to be prepared for these kinds of calamities. So it is 3,300 times more energetic than the magnitude of earthquake, and so on. So the results can be really very, very panicking. There are other associated effects, smaller ones, but this is the major thing. So the research on near-Earth asteroids took a serious turn of event after, say, estimating the actual energetics. And then you see that there were very small efforts to trace them before 2000. But then, as you can see here, other methods have started picking up from 2000 onwards. And once you improve the technique of finding the near-Earth asteroids, the number has grown. It's still growing. And so that's what the first graph I showed. So many of them coming closer to the Earth, and so we will have to be prepared for that. And so this is the linear Lincoln Near-Earth Asteroid Research Program. There are so many telescopes. There are pairs of telescopes situated, and if there is a streak moving in the sky, immediately it tracks and alerts all the astronomers, so that the others also continue. Nowadays you will have so many space debris also moving, but they have a method to segregate them, so it's happening automatically. So they produce a list of potentially hazardous near-Earth asteroids and alert people on the possible date of crash also. Then there were many space experiments to avoid these kinds of things on a different scale. This was one of the first ones in 2005. So they measured the energy. So they made an impact artificially and tried to extract how much of energy is involved in this kind of a procedure, and what was the effect of that on the asteroid. The change in the orbit was only 10 centimeters. So now you realize what kind of an effort we should be putting for avoiding these kinds of things. That means to prevent them coming close to the Earth by changing the orbit. The other is putting a satellite to the asteroid so that the energy budget will change, and that will slightly take it away from the dangerously close encounters. So this is another method that is being used, attempted. I cannot say it is being used. They are attempting this also. Then there is a third very interesting one. That is, you focus solar energy. See, these are quite loosely packed rocks. So once you focus the sunlight onto them, then it vaporizes, and this recoil itself can be quite significant so that they move away. So this is another mechanism that is being worked out, and some of them can be put into practice and experimented, but it's not that easy. There have been so many missions to various asteroids in the last so many years, decades, but to try out an experiment like this is not always very simple. So this is one, and then Japanese sent a mission to Hayabusa to Itokawa. That's the name of the asteroid, and it successfully landed there, picked up some material and brought it back to Earth. And when it was brought back to Earth, this photo shows the re-entry. The outer things burnt up in the sky, and the central portion, which was holding the sample landed safely and they picked it up and studied. In fact, there is a Hayabusa 2 also because they repeated this on a different asteroid. So this Osiris Rex also is one such thing, and this was in news because in last December, it also brought back some material from an asteroid, and that was also picked up for studies. Hayabusa 2 also brought back material. So that tells us about the nature of the asteroid, and if you are planning some kind of an experiment that we envisage till now, whether it is realistic or not. For such purposes, this study is very important. And okay, these are the names of the Bennu is the name to which Ceres went, and Ryugu is the one for which Hayabusa 2 went. And you see the sizes there, they're not very large bodies. But in fact, if one of them lands on the Earth, what would be the consequence? That's the kind of thing that we have to follow. And then by any of these, if we are able to break it into pieces, then what happens? Whether they can be broken at all. In case of comets, it's known that they are very loosely packed, but not so in case of asteroids. So this was another experiment that was done in 2 years ago. So you have this is the binary asteroid, and then they did this impact onto one of them, and tried to find out how much the orbit deviated in this process by artificially making some blast happen on the companion, and the orbit changed. 32 minutes. And that is shortening the 11-hour 55-minute orbit into 11-hour 23 minutes. So this was the photograph of this event taken by the Hubble Space Telescope. So that means this is doable. To what extent we should be planning the whole mission, etc. So this gives an idea of the insight into the future projects. So now I mentioned about Ceres. And we are back on to Ceres because there was a spaceship called Dawn, which, see, this is the orbit. So it managed to reach Ceres finally in the year 2012. It went very close to it and took some images, close-up images of that. And one thing that was interesting about this Ceres was, I told you it's a perfectly spherical body. It has no atmosphere. So it was mistaken for a planet and then became an asteroid. Now it became a dwarf planet. And this is one of the close-up shots of that. And what is interesting is this. What is this white patch here? This patch was not visible from ground-based telescope, but this showed it. So whether it is ice, if it is ice, then you can have some hopes of finding life there. So that means you can use it for a future column. So this is the kind of ideas that is on Ceres now. So Ceres is a very important object for study. Okay, now I have to tell the names of the asteroids because that was in news recently. The very first name, well, there were many Indian names that went into the list. They are named after personalities, celebrities, and so on. So the first name was Venu Bapu here, this person who established this institute. This happened in 1985 itself. One of his close associates discovered a comet, discovered an asteroid, and the discoverer usually will have the choice of naming it, so he decided to name it after Venu Bapu. There was a team here working on planetary systems, and they discovered these 4 asteroids. They named them as Ramanujam, J.C. Bhattacharya. J.C. Bhattacharya also was the director of this institute. M.G.K. Menon, the famous scientist who also helped this institute come up by being the governing council member. And of course, Vikram Sarabhai, you know him very well. And the fifth one, I think, was named after Murnalini Sarabhai. So these five were discovered from this. Subsequently, one guy also was discovered by Dr. Bhargavi, but I don't think she gave any name to it. But then, in recent years, last year and this year, you have the names given to asteroids of Professor Jayant Murthy, who till about 2 years ago was the professor here. He is very active in interstellar medium studies and so on. And the other person, Ashwin Shekhar, some of you may remember, he used to be coming here as a student. Now he is working on meteors, not in India, outside. So these are the names associated with IAF. There are other people from India whose names have been given, like one young boy, Amar Sharma and Vishnu Reddy. All these names have been there, but I chose to show only the names associated with this institute. Okay, so that is how the asteroid day becomes important. I think I have conveyed what I wanted to tell you. If there are some questions and if I know the answers, I will answer. Thank you.
Thank you, Dr. Shyalaja, for that. We can take some questions. Can ask our volunteers to take mics around. Are there questions? Something you'd like to know? Something you'd like to ask? Oh, there's none? Huh?
Yeah.
Can we just wait for the mic?
Asteroid impacts can change the climatic condition of the region.
Sorry, one sec. Can you speak into the mic? Yeah. Yeah.
I have a doubt like whether these impacts can change the climatic conditions of the region, especially you showed an asteroid which is like that USSR region. Whether it change the climatic condition of that
Yes,
region.
yes, because they
How
will
does it
create a huge dust cloud. When the dust cloud comes, then the atmospheric disturbance will be there. And then it can block the sunlight substantially. So there will be a change in the climatic condition. That's a slow process. But immediately, for a few days, you may not see any sunlight at all. So in the middle of summer, suddenly there is no sunlight. Some such things can happen.
It's a long-term impact.
Long term and short term, both are there. I mentioned about the crater in India, Luna. It's off Mumbai. It's somewhere close to Mumbai, Bhuj, somewhere there. And there also they feel that it must have caused some severe disturbances in the climatic conditions which impacted the life there at that time.
What about the soil conditions?
Huh?
Landed on some kind of land. What about
Land,
structure of
land
the
only
soil?
is catastrophic.
No.
If it is on water, then only tsunamis.
What about the conditions of soil, chemical composition of soil? Whether
Yeah, this Lonar crater in Maharashtra near Aurangabad. It's called Lonar because the water is salty. If you go there, you can feel the difference. Even today, people go there to collect samples of small meteorite stones there. So it was a huge impact.
in the entire ecosystem.
Yes, it must have.
Okay. Next question. Over here.
Thank you for the talk, ma'am. My question is, why are the asteroids in the solar system where they are? Like, why is it between Mars and Jupiter only, or trans-Neptune?
I told you that this is called a refugee camp. Okay, so thus they were kicked out from the inner side and from the outer side. So they are in the belt between the two. This is one of the things. Then how do you explain the ones on the other side beyond Neptune?
Yeah,
Similar
that's what my
argument.
question is.
Similar argument there also, because the planets used up all the material that was available near them for making its own sphere, its own globe. But what about the ones that were left behind? They were thrown away. So they gathered to different.
There's a question here.
Ma'am, I have regarding doubts on binary asteroid and difference between crackery and comic. Comic asteroids.
I didn't get the word comic asteroid.
Do you mean a comet?
Ma'am, first doubt is binary asteroid. Ma'am, I have few doubts now.
Please, what
Ma'am,
is
you
it?
told Galileo in he.
Galileo spacecraft
Yes, ma'am.
discovered an asteroid which happened to be a binary. That was the first one. Till then, people imagined, but then no photograph was available. Okay, I think its name was Gaspra or something like that. What's the second one?
Ma'am, the second one is the Krakerian asteroid difference and comic.
I didn't get the word comic.
Sorry for misinformation. Krakeri difference.
Not
Okay.
even
So maybe you can catch it later and
later.
and ask
Maybe
about
some
that.
word
Yeah.
I have misread or something.
If that's the question, we'll come back to you.
Good morning, ma'am. I want to know what are the initiatives, the asteroid, the impact initiatives, like how to prevent them or hitting the Earth. So, is this a kind of global initiative taken by all the institutions across countries, or we constantly only hear about US space scientists always talking about thwarting the impact of asteroids, and always we get to read more about them, talking in terms of thwarting all the asteroids hitting our planet. And they are the kind of custodians of, or whatever, kind of creating a safety net for the people on Earth. But we never get to hear about the Indian, from the Indian side, what are the initiatives taken or what is being done?
There is an international committee
Okay.
for space research. So they are the ones who organize meetings and hold joint sessions wherein people discuss the various aspects of what I showed here as only some fictional pieces. And these are research papers and experiments and other ideas that were carried out here on the Earth. They are discussed there, and the pros and cons and the possibility of a project for that will be discussed in the international meetings. And who will take up that will be decided by agencies like NASA or JAXA. So it's at a very different level. And I think there are many Indians who are also involved in this thing, but they will be working at the research level, and it will be in a group. So finally, when the mission is announced, it will be by NASA. It will be by the European Space Agency. So that name will come in the newspapers.
Okay. So basically, the Indian institutions will work on the background research and trying to identify
Yes.
or the impact or what is the possibility of any asteroid striking.
Yes.
Is that what the Indian institute will be primarily contributing?
Yes.
But the actual action of what you showed of having a satellite or
Any of these methods.
reflecting the sun's the light on the asteroid to slow it down, and all is done by there is no institute in India which kind of does it. I'm just asking you.
I have no idea.
Like our agencies like ISRO and all.
I don't know any such project by ISRO. Perhaps you can ask ISRO.
No, generally the question came from because we generally hear from more from the US.
You also have to think of the money that is involved in a project
correct.
like this.
Got it.
And it's not going to be 1 or 2 year project. Going to the asteroid itself will be a 5-6 year thing, and acting there and bringing it back, etc., will be another 5-6 years. So it's a very long duration.
Long duration. Okay, one more question is that how many asteroids the scientists or the people involved have been able to thwart it, coming and striking to?
No, I don't think.
Is there a number or some?
You mean how many
Asteroids have been like prevented?
No, prevented. No, not even one. That's only an experiment happening somewhere far away, and those objects are not going to be coming anywhere closer to the Earth at any time. These are only experiments. Okay. And how many asteroids are approaching the Earth? There is a website which will give you the list of them.
Okay.
So it gives the date and the distance in lunar distances, LD it will give. So they are predicting that something is coming next week. And somebody may pick it up and put it as a front page news, but it will make no impact.
It will
because
fizzle out.
It will make no impact on the readers also, because it's at a very safe distance. So,
So it won't approach even.
No.
It won't even approach them. It
No.
will just fizzle out by itself.
it will be useful for those kinds of radar studies and so on.
So it's not like you're going to see a streak of light in the.
Right.
No, you
So
may
the
not
event
even
what
see
you
that.
showed about that one pit in Rajasthan or in the midst of the field, what you showed. So what are those? Those are like rare kind of events?
No,
would you
but
consider?
there is a group working on that, and Professor Narendra Bhandari has been very active. He was working in physical research laboratory, and he has studied these meteoroids extensively. So he has a very large team, and he is the inspiration to many youngsters who keep who follow these kinds of news items, go and reach the spot and pick up the thing. Otherwise, it will be forgotten. No? That's active. Even last week they identified.
Oh, is it?
So we'll move on to the next question. due to lack of
Thank you
time.
so much. Yeah, sure.
Right, sure. We'll take one more question after this, and then.
Good morning, ma'am. So we know that asteroids are rich in minerals and they can be used to make rocket fuels and some space structures. So are there any projects planned for space mining activities in the near future?
Yeah, that's the long hope. You can go and mine diamonds there or gold.
There are asteroids made of gold,
Yeah,
so we might as well.
that's for you. You people design something. But if you have so many diamonds available freely and distribute it all over the earth, it will lose its value. Not to remember that also.
The next question right behind. This will be our last question for the day.
Hello, ma'am. My question is, how successful are we in studying the impact of asteroids under sea? Like, are there, except the tsunami thing, are there any studies going on undersea of the asteroid impact? Like,
Yes, there should be plenty of them. But the difficulty is they get wiped out because of the water. So that shape, that typical circular shape, which is the identifying feature, you won't be able to make out. So even it's the same with Arctic regions, Antarctica. There also, if there is a crater there, then ice fills it up, and only when the ice melts, you will know that there was a crater there. So these are the. But then Antarctica is a very rich source for collecting these kinds of meteoric stones. So people just go and dig out, and they can pick up so many stones. In fact, one stone from there, they studied and said this is from Mars. So somehow from Mars one piece had come and fallen there. All these kinds of studies are being done. So Antarctica is a very rich source for meteorites.
Okay. Definitely not a reason to melt the ice of Antarctica, though.
No, you can't. You need not. You need not break. You can
Yeah.
just go and dig.
Which is naturally melting by our actions.
Okay, thank you again. We'll thank Dr. Shyalaja again for the wonderful talk. And that's the end of our YouTube live stream also. Now for the next part of the day, we're running behind schedule by about 15 minutes, but I think that's okay. The next activity is something that Robert Hooke sort of came up with back in the 1600s, and something that we also saw on the moon, which is the recreation of impact craters. We're not going to throw